All right, guys, we already passed 5 minutes. Let's get started. Uh, right, so this is going to be one of the continuation from our yesterday's demo class. This is going to be second demo class. Let's quickly uh, touch base on what we covered yesterday, and then we'll get started with the today's planned sessions. So quick one more announcement. What we covered yesterday. We covered yesterday with the introduction about me, course curriculum, course details, and some of the basics of Linux and networking and types of databases, and a little bit on the database side, that installation part, right? So now I can quickly talk 1 or 2 minutes on the again course curriculum and the course timing, and then followed by we'll go with as per today's planned topics, whatever supposed to be covered. So again, like you can always go to my blog and then check for the course curriculum if you not yet done. So this is includes your the entire course curriculum, whatever plan to cover as part of this course. So we already covered this in details in yesterday's demo sessions. I request them to go back and refer that recordings. And if you have any questions, queries on that course curriculum, like if any topics is missing in this course curriculum, and then you feel free to provide your feedback, or anything is not included or anything need to be included, so feel free to discuss with me, or any questions around this course curriculum, always happy to take it as a feedback and then improve our course curriculum. Right, with that, again the course details. So today 2nd Feb and sorry 3rd Feb, yesterday 2nd Feb, so Thursday and Friday are two demo classes, and starting with Monday, so that's where we're going to start the actual course. And this is a weekday batch, so Monday to Friday, and no classes on Saturday, Sunday. So pretty much you're going to complete this course by within these 45 days, right? So course fees is 10,000, and yesterday and today were the demo classes, and followed by Monday we're going to start the actual class. And the actual class timing is are going to be remain same, 9 a.m. to 11 a.m., 2 hours on each days. That's 10 p.m. EST to 12:30 a.m. EST, and approximately 45 days is the course duration. Right. With that already covered, what are the advantages or what all you will get it at part of this course? All the PPTs, workbook, lab material, softwares, ready VMs, and previous batch recordings, and everyday sessions will be recorded and uploaded to Google Drive. And whenever you miss a call or miss a class on a particular day, you can always go back and refer those recordings. And a dedicated WhatsApp group for each batch, so that you can discuss, ask questions, queries, and we'll be conducting some extra classes after the course. Will be discussed everything in that particular dedicated WhatsApp group. Right. So again, these courses, materials, and recordings are all lifetime accessible from the Google Drive. So no restriction on that. And again, one more advantage is, like as I said yesterday, so if you suppose register for this course by making a payment, and if you're not able to attend or you're not able to continue due to certain reasons, you are traveling or your health is not well and you have some emergency and family emergency, and you disconnected the course, no worry on that. So whenever I start a new batch, so you are feel free to attend that live classes, no need to pay any extra money on that, right? That's other feasibilities as part of this course, right? And then I got a lot of pings after the class about the payment details and all. Always, as I say, like you can reach out to me on my WhatsApp number +91 98806168848 for further processing or registration process or the payment. So I'll guide you in that direction, right? So yeah, that's a quick again intro about the course details and the course curriculum. Let's get started. If anyone has any questions, I'll take a pause for 1 or 2 minutes on this topic you want to discuss or queries, concerns. I'll happy to discuss on that. Otherwise, we can go with as per the today's session.
Hi
Right.
Malik, this
Yeah,
is
please.
Pritam.
Yep.
Yeah, I have a question. Like, are you going to cover anything related to unified auditing or standard auditing
No,
and VPD,
no.
virtual private database,
What is that?
VPD, virtual private
No, no,
database,
no, no, no,
at the data masking,
no.
TD? No,
TDE,
okay.
no, no.
Okay.
Your wallet,
So,
TDE, OEM, your Golden Gate, and auditing, and these are like, database vault and database level security. Those are like advanced security construct topics which will be not part of this database course.
Okay. So after completing this course, like I will be like good enough to go for the OCP 19C exam.
Right. That's
But
correct.
in that, like auditing is part of the curriculum.
That is extra you need to cover it, you need to grant on that, because this part is not particularly pointing to OCA or OCP. This course
Okay.
is combining together OCA and OCP, and then we're applying it in one particular training.
Okay. Okay. So
Right.
and last question is like when like this is the course, like I think it will end on March, I believe.
Right, mid of March.
And again, like one more batch also you are going to start in March.
Not exactly. That depends upon the time and then the request. That
Okay.
again, which you cannot predict.
Okay, thank you.
All right.
Malik, will you cover like ADDM, AWR report?
Right. That'll be part of the course.
I mean, how to read the
Yeah, that's correct. And you can go through that one. It will be part of the PT sessions, probably chapter number 22, 23, 24, where ADDM, AWR report, ASH report, and so many other reports. We're going to cover it over here. Your SQL tuning, SQL advisor. All right. So, any questions?
Hi, Malik Bharat. Hi, Malik Bharat here actually.
Hey, Bharat. Yeah.
Yeah, actually we get the softwares and EMs to download and install in our laptops, right, for practicing.
Right. Right.
Yeah.
Everything will be provided.
Oh, sure.
All right. Again, you can see. Again, you can see over here, right? So you will be getting your PPT, PowerPoint presentation, whatever I'm representing, your workbook, lab materials, and all the lab softwares, ready VMs, and previous batch recording, some of the basics of rack understanding before you going to rack classes, and some of the daily logs, whatever I'm gonna capturing, everything will be uploaded along with the everyday session recordings, and some like whatever, it will be part of your course curriculum, and it will be available in the Google Drive, and you can access them. And these are like lifetime accessible materials.
Sure.
All right. Any questions, guys, before we get into a technical discussion for today? Anything you want to know about me or about course curriculum or course timing or the course fee structure? Or feel free to ask. This is a platform, you can always ask any questions.
Malik, are you covering OCI concepts?
OCI, no.
Hello, Malik.
Yep.
Yeah, my name is Tasha. I want to know, is this course geared towards just obtaining the OCA, or is it practical
OCA,
in such a way that after that you can be able to handle a database of a company or something like that?
this particular course, as I already explained in yesterday's session, if you missed it, you can watch it. So this particular in Oracle, majorly 3 certificate, your OCA and OCP and then RAC. These are the 3 certificate. And this particular course is mainly meant for, obtaining your OCA and OCP. Whatever needed for OCA and OCP combining together, this particular course is formed. That's one fact about this course. And the second fact about this course is, and if you can go ahead and then check it about the course curriculum, this course is targeting, once you complete this course, you work as a DBA in any enterprise organization. So these are the tasks in an organization as a DBA will get to work on in day in and day out. So that's the second aspect of this course. So one is certificate, OCA and OCP, and other one is you will be able to work independently as a DBA to join any organization. So these are like overall my 15 years of experience as a DBA, whatever needed for working in any enterprise organization. So based upon that aspects, this particular course curriculum is formed, and it will be on pure practically and real, real time world, what exactly comes into when we start working at the DBA. Considering all those aspects, this particular course is formed. That's the second aspect of this course. And the third aspect of this course is, and once you complete this database course, you can mention or you can work as a DBA from 1 year to 3 years. You can pretty much mention in your resume with 1 to 3 years of experience, and that's a leverage this course is providing. And coming to rack is a separate course we'll be conducting, and that rack once you complete, and you can pretty much mention in your resume from 4 to 8 years or 10 years. So that's a second course what we're conducting.
Thank you.
Are you covering continuous size to cloud
No,
migration?
no. Right. So there are a lot of advanced topics, right? Your Oracle Cloud is advanced topic. Golden Gate is advanced topic. Your Oracle Enterprise Manager OEM is advanced topic. Your Oracle Wallet, Oracle Vault, and database auditing, OS auditing, and there's so many advanced security concepts. So those are not covered as part of this course, but definitely if majority of students are interested to know any of the concept, for example, your database migration from on-premises to cloud. For example, database migration from Linux to Windows, database migration from Linux to AX, or Linux to any other platform. These are like advanced topics. Anyone interested will be covered or will be taken as a extra topic after end of the course based upon the majority of vote, like who are interested which all topic, and we'll discuss in our WhatsApp group, and we'll take 1 or 2 extra sessions. Will be covered these topics based upon how many people, how many students are interested. Those will be taken into the extra course, extra probably extra topics. All right. Let's quickly share my screen once again. Any more questions, guys? All right. If no questions, let's get started. Some of the technical discussion. We'll start with the database architecture and followed by database connection. And then we'll see how the time goes and we'll cover a few more topics on that. So what I'll do now, I'll just give a simple comparison. I think yesterday we covered as a DBA how we'll install a database on a particular software. It may be, again, we covered types of databases, right? It may be standalone database or Oracle Restart database or RAG database, any database. We already covered yesterday how we can download the software and how we can install it on a particular server. And now let's understand like what we did yesterday. Again, I'll take a same example. So my London data center. And then in the London data center, we have so many servers, right? So we have so many servers in my data center. It may be database server or it may be application server or whatever it is like, and I'll be running a company abc.com. And one of my database server is, let's say Oracle lab1.abc.com. And one of my other server is Oracle lab2abc.com, or so many other servers, which is residing under my data center. And I have installed my databases on Oracle Lab1 and Oracle Lab2. We install many databases. Assuming that this is one of my database called DevDB, and this is my one of database TestDB. So we install it, and anyone, for example, as a DBA, if I connect to my server here and I can access my database without any password, and as an application team, and this is the app server, like apps.abc.com. If application user who connected to app server, how they will connect to my database? They will not be having the application user. They will not be having access on that database server. For example, if I can bring here Oracle Lab1 and where my DevDB is running, my DevDB database, which is running under Oracle Lab1. And then in Oracle Lab2, ps-ef grep smon, my TestDB, TestCDB, so many databases were running here. As I showed here, the DBA, I can log in here, right? If you observe, if I check my database, running database here on this Oracle Lab 1, DB is the database which is running, and this database is ideally owned by Oracle user. This is the OS user or the OS owner. So if I can host name -I. So if I can take one more session directly at the Oracle user or with your own user, for example, as we talked yesterday, you can log in with your own user ID. Like, let's see, I'll log in with the Malik user. Right, once I log in with the Malik user to the database server, I can switch to Oracle user with a sudo or with a su with Oracle user password. Once you log in, you will pretty much log in as a Oracle user to that server where your database is installed or your database is created. Right, again, one more time, ps-ef grep smon and DevDB. This DevDB is owned by Oracle user, and you already logged into that server, the Oracle Lab 1 database server with the Oracle owner. And once you log into that Oracle owner, you can pretty much connect using SQL Plus as sysdba. You don't need of any password. You don't need of any username to connect to that database. Like, I'm going to set the environment to that DevDB, and I can use SQL Plus as sysdba. So here, if you see, I'm just using SQL Plus library, and I'm not giving any username and password. So without username and password, I'm able to connect to my database because I logged into that server, Oracle Lab 1, where my database is installed. And in fact, I logged into that Oracle Lab 1 as the Oracle user. Oracle is the owner for that particular database. So if you are logged into the database server as a owner, and you don't need to give any username and password, you can use this called OS authentication, and you can connect to that database. So that is called local authentication or the password authentication, because you are the owner, you installed that Oracle database and you already logged into that server, a Linux server, and you can pretty much use SQL Plus library, and without username and password, you can connect here. So this is called local authentication or the password authentication, sorry, local authentication or the OS authentication, and you don't need of any username and password to connect to your own database, right? It is you installed and it's your baby. You can do whatever you want. But whereas when it comes to application server, you connected here, application server, and you want to connect to that database. You want to access only database. And for example, here Oracle is a user, and you logged into that Oracle, that Linux Oracle Lab 1 server with Oracle user, you can connect to the database. In your Oracle Lab 2 also, if you logged into that server as a Oracle user, and you can pretty much connect to the database. But here in this app server, one apps user or user 1 or anyone logged into that app server, how they will connect to my database? They will not have access to that database servers because those are like application users or application server level users. How they will connect to my database? They have to use their username and password. First, we need to create a username and password to that particular database, and they have to use their username and password to connect to my database. That is called a remote connection. And in order to do a remote connections, we need a username and password. So let's understand that connectivity part first, and then we'll go with the architecture part. So what I'll do now, let's take an example here. What I'll do now, I'll just go here. This is one way, like from application server, if anyone want to connect to my database, they have to connect as a remote connections. Let's take one simple example here. And Malik 1 or like Oracle user connected here. Let's see, like Oracle user connected here on this particular lab 2, and he want to access a database which is available in lab 1. Again, this is considered as a remote connection, right? Not necessarily from application server connecting to database is a remote connection. Anyone connecting to my database from the other server, it's all called remote connections. Let's take example between lab 1 and lab 2 connections. Let's go here. Right now, I am here on my lab 2, and I don't have DevDB database here because DevDB database running under lab 1 here. How I can connect from this Oracle lab 2? I want to connect to my DevDB database, which is running under Oracle Lab 1, right? What I covered yesterday, in order to do a connections, you need host name where your DB is running. That will be your Oracle Lab 1 and your DB name. Or you can call it as a service name, that will be DevDB. And the port, on which port your database is listening, that will be 1522. Right now, this particular DevDB is listing under 1522. And a protocol. So your database is listening under TCP protocol. So you need all the details. Along with that, your username and password inside DB. So inside the database, first you need to create a username and password. And along with this username and password, you need all these details. And then you will be able to connect to that DB database from the remote server, any remote server. It may be application server, or it may be any application or anything. Let's take a first example. We'll meet this criteria, username and password. Let's create one dummy username and password inside my DB database. So right now, I'm into that Oracle Lab 1 as a Oracle user. I can connect to my database without any username and password because I'm the owner of that database. Right. I'm connected to my DB database. You can pretty much select name from $V database. Right. Again, don't worry about what are this $V database and all. As we proceed with the real course, we'll talk about what is this $V. That's called dynamic performance views. And this is a view, or there are some tables, there are some views, some synonym index. So those will be discussed as and when we start the actual course, right? So now I connected to my DevDB with my OS authentication, local authentication, without any username and password, right? If I do show user here inside my database, I connected as a sys user. Sys is a master user for my database. For example, in Linux system, root is a master user for any Linux operating system. Similarly, for any database, sys is a master user, right? So I did not mention anywhere sys username. I did not mention anywhere password of that sys user. I am able to connect to the database with a master user. That's one thing because I am the owner of the database, right? Now let's meet this first criteria. So any remote connections or any application connections, they need to have a username and password inside my database. What I'll do now, first I'll create a dummy, create user apps identified by apps. So this is the way how you can create a user inside a database, right? You created a user and I'm going to grant some privileges for that user. Again, we'll talk what is this grants, privileges, permissions once we start the actual class. But right now, my intention or my motto is to just to get one username and password inside my database to show you remote connection. Right. So I'll just give on some grants to that username. You can validate using describe db underscore users is a command. You can check select username comma account status from db underscore users where username equal to apps. So again, I'll just format it, set pages, 1000 lines, 1000. Again, what is this formatting pages and lines? We'll discuss in further classes, but now I'll just format this output. And your app's username and account is open. It means whatever the user you created here, apps user inside this DevDB database, it is all working fine. It is all open status. So now we got username and we got the password. So let's put it here. We met the first criteria, apps username and apps password. We got the database level username and password. I can give it to application team to connect to my database. And the same username, entire application team can use it. Hundreds of connections, they will do it for my database. 100 users, 100 times they can connect. All the parallel connections, no restriction at all. Right, protocol and the port and the DB name. You are going to decide all this as part of your database creation. So if I can check it out here in the Oracle Lab 1, there's something called listener. For my DevDB database, I created listener underscore DevDB. So LSNRCTL status listener. This will be decided at part of your database creation. And if you observe here, your host name, and your protocol and your port. So we already defined these details as part of our database creation. Right, you can see here, you can change it anytime. It's all dynamic. You can change it anytime. So your protocol, TCP already defined, host name already defined, and port already defined. Is everything is defined over here, right? And then we got the host name, we got the DB name or the service name or the port name and the protocol, and along with the username and password, everything is decided. Now let's go to your Oracle Lab 2, and then I'll put all of them into a called a TNS file. This is a TNS file, and I'll put all those details, whatever we got here, into a file called TNS files. Like this is a DB database details. What are those details? Protocol, TCP, that's correct, and host name, Oracle Lab 1 localdomain.com, and the port is wrong here, right? So if you use anything wrong information, and you'll not be able to connect. Let's try to connect now. SQL plus, I want to connect using apps user and followed by that apps password at the rate which database I want to connect. I want to connect to DevDB. Right. So this is the way when anyone want to connect to remote or remotely, they have to use SQL plus or any library to connect to my database using a username and password followed by all those details. What I did here, my protocol, my host name and the port along with my service name and database name, all these details I put together into a alias name DevDB. I'm going to use that DevDB here. And if I try to connect, it has to connect from this Oracle Lab 2 to Oracle Lab 1, and it has to connect to my DevDB database remotely. Right? This is a DevDB database. And now if I try to connect here, it will fail. Why? Because I'm using a wrong port here. Right? TNS no listener. It means whatever that listener which is running on the server side will not be able to connect because there are no listener running under 1521. Our listener is running under 1522. Let's go ahead and modify the TNS file now. VI, and I'll go and modify the TNS file, and then I'll put the correct port now. Right, let's go ahead and put it to 1522. That is the correct port your database is listening. And now try to connect SQL plus and the username inside your database and the password and connect to your database. Right, I'm able to connect. Run the same command, select name from $, database. So you are able to connect to DevDB, which is residing on remote server using a remote connection. This is your called TNS names. So you need to know all those database details, whatever I mentioned here, the port number on which port your database is listening, and protocol on which protocol your database is listening or your database is operating, and your database name or the service name, and along with that, your username and password. And if you forget username and password, and you will not be able to connect to database. Let's try that as an example here. Instead of apps, I'll use apps11. This is obviously wrong password. This username is a wrong password. And if I try to connect with that, it says username or the password is invalid. Right? Either you can do a wrong password or you can do a wrong username and it will not be able to connect. Let's take one more example. Apps password is correct, but username I'll take it as the apps11. Again, that apps11 user is not at all available inside my database. Right? Again, invalid username and password. Right. Let's reproduce one more example. Now your service name is equal to your database name. So that's your the requirement right here. The DB name, you should know that one. And now if I make the DB name wrong, and then I will not be able to connect. So let's go here. I'll put DB name like this, DevDB11. There's no DB name called DevDB11. There's only DevDB. And try to connect now. With the correct username and password, with the TNS name, and it will fail. It says TNS listener don't know the services. Whatever the listener running under my server side, this particular listener don't know what database you're trying to correct, what service you're trying to connect. That is DevDB11 you mentioned. And listener is telling, I don't know what you are trying to connect. The database is not there in my list. So these are like common issues as a DBA regularly will face. Our developers will send this message, I'm unable to connect to my database. Developer will send this message, it says invalid username and password. It says TNS connection lost. So all those details, all those issues as a DBA will work, because there are like hundreds, thousands or lakhs of connections, all will comes to your database via remote connections. Whatever you are seeing it here, nobody has access to your database server. Only DBA has access to the database server. If I'm a DBA, I connected to my database server, I can pretty much use SQL plus /SSDB. I don't need any username and password for my database because I'm the owner, I can connect it. But apart from DBA, anyone connect to my database are all remote connections. And these are the common issues. When we start working on a DBA, we'll regularly get this one. My user account is locked, my user password expired, and all those things. We're gonna handle those all the incoming connections. So properly we need to guide them. We need to give what TNS connection they're using, what username password they're using, and whether that username password is exist inside my database or not. And if that is exist, and whether the account status is open or locked. All those things as a DBA we can validate, and then we can guide them in a right direction. Right. So that is for the database connections. Any questions on that database connections? Either it may be a local or it may be a remote connection.
Malik, imagine if customer wants to connect to multiple DBs. So then we have to go ahead and edit the TNS names .ora file, right? You can give multiple DBs in it.
Right. For example, if the server is running with multiple databases, for example,
Correct.
this is a customer has access on this Oracle lab too. He logged in and he want to connect to multiple databases, multiple running, like one database is running here, one database is running here, one database is running here, and they have to give that TNS name multiple times on that TNS name.ora file. Right, cat
Got
TNS
it.
name.ora file. Like this is one entry, DB, and he can add the test DB, he can add a UAT DB, prod DB, and DB1, DB2, hundreds of database he can add it into this file. And while collecting, he can use that alias name, whatever he mentioned.
Got it. Got it.
Right. Right. So that is about the database connections.
Malik, actually, I have one doubt.
Yep.
Service name will be here the DB, dev DB, and
Most
alias
of
name
the
will be
time,
different.
most of the time, your service name is equal to your DB name, and you can change that service name. Customization, you can do whatever you want.
I mean, is it mandatory to keep the database name and service
Again,
name
as I
same?
said, it's all customizable. It's all online activity, no downtime, nothing. You can do whatever you want. But ideally, standard practices, your DB name and service name are going to be same.
Alias name will
Alias
be
name
different.
also you can put anything. Again, as I said, this is the mapping you are doing. This is what I need to connect to my database, and it doesn't matter. I can give Malik here. I'll show you one more example. So that is just like, okay, let's talk about one more. Why I'm gonna keep, why we ask customer to put all these database details into alias name? Because let's take this as an example here. What I'll do, I'll remove this one, and then I'll remove everything in one line. I'll make it everything in one line. Let's see this one. Sorry, let's remove this one and then remove this one. Right. So this is actual correct details. They have to put it in the format only. Any mistake if you do in this format, it will wanna fail the connection. Right. See, this is your description, address. We're mentioning all those protocol, host name, port, and connection to that server. Everything you have to put it in this format. Every time customer want to connect to my database, they have to use this entire details. Let's go here. Right, I'll put in double quote and I'll put that entire details, and then they're able to connect. Ideally, to connect to my database, they have to use SQL plus password as username and password @ every time he has to write this entire thing. To avoid customer to write entire thing every time they want to connect, the Oracle has came up with this alias name. Was like, if you're not interested to write this entire big string, put everything into this TNS file and give whatever the alias name. Right now I gave Malik, sorry, DevDB. I can give the same details, and then instead of DevDB, I can give my name. Doesn't matter. This is just like alias name. I'm giving it for this entire connection string. Let's go here, remove everything. It not necessarily have to give the same name as the DB name. Right now, instead of David DB, I can use Malik, whatever the alias name I can give. I gave it in that INS file. It's all like making user friendly. All right. That's for database connections.
Yeah, Malik, one doubt regarding the connection to the DB. So when we are connecting the DB as SQL plus / as sysdba, it is like connecting to the OS as root user, right? Suppose if there are other DBs
Right.
created by many other users, so we can
Right.
make changes to all the DBs when you connect like that, right?
You have to source that. Okay, that's a good question. Let's talk about here. And if one single server has a multiple databases, for example, this Oracle Lab 2 has how many databases? TestDB,
Two
TestCDB.
DB.
And this TestDB is created by my development. And this is TestCDB is created by my UAT team. And make sure that who is the owner of the databases. Right now, Oracle is the owner for all the databases. In certain scenario, TestDB is created with Oracle and TestCDB is created with Oradev and TestUAT is created with UAT. You will need to first log in with that particular user first. Unless if you don't log in with the owner, you'll not be able to connect to the database. Let's take one example here. If I log into Malik and then if I do .env and set the environment to TestDB, and I'll not be able to connect to the database, right? Even though if I logged into a Malik user, and if I try to connect SQL plus / as sysdba, and it will not allow you to connect because Malik, you are not a owner of my database, boss. You need to log into that respective owner first, and later you can do whatever you want because you created my database, you created this database, and you can do whatever you want. Make sure that you log into that owner first, and later you can use this OS authentication. Right. Let's go back here now.
Malik, this is Suleiman. I have a question here.
Yep.
Since you are saying that you are you can have multiple owners, right? Like you said, Aura Dev, Aura UAT, and others.
Yeah.
Can they share the same Aura home then? No, right?
We'll talk on that a little bit later here in the next slide.
Okay.
Right, let's talk about a little bit now. So if the connections are all fine, yesterday we covered about the installation, how you can do installation. Now we talked about that after the installation, how you can connect to your database, how DBA will connect. DBA will pretty much go to the server at the Oracle user, and he can pretty much use this OS authentication to connect, to do manage, to operate my database. And how the remote connection works, they're going to use the TNS names or TNS connections to connect to my database remotely. Right now, installation done and connection part is done. Application users also able to connect. DBA also able to connect. Now, how the database architecture work, how the transactions works. Let's understand a little bit on that as comparison with our human life. Let's correlate this database concept with our day-to-day activities. Like I'm a human being and one of my friend or somebody comes to me and then give some instruction, like, one of my friend comes and tell some address. Okay, can you keep a note of this address? We'll go to that address. Or like, one of my friend comes and he will tell, okay, let's plan for next weekend some trip. And he'll give the details and resort details, address and all those things, right? So the moment my friends plans or instruct me anything, and then as a human being, what I'll do, that instruction, I'll try to keep it in my mind. I'll try to remember that things, whatever the instruction, whatever my friends, whatever my colleague tells, I'll try to remember the things, right? At the time being. And then what happens after over a period of time? Am I able to keep that forever in my mind? Over a period of time, I may forget the things, right? What I'll do in second task, whatever the instruction I got, whatever the information I got it from my friend, I'll start writing into some notebook. Because I may forget it because I cannot remember everything. I will start writing into a notebook, right? And then again, many people or many friends, many colleagues will come and will discuss a lot of things and they will give a lot of instructions. And then I'll keep on writing into a book. And once eventually one book is full, I can take one more book and then start writing into that. I can form multiple books, right? And then after certain days, the same colleague or same friends comes, okay, do you remember I told you some address of some restaurant or some resort? And if I remember the things, I can immediately respond him back. Okay, yeah, this is the address you told me other day. And if I don't remember what I'll do, I'll go back to my books, I'll refer that where I written, and then I'll give it back to that. Right? That is a human behavior, like everyone will work in this manner. And same thing you can correlate to our database. What happens? A user connected to my database. This is your database server. Database server is a combination of instance plus a database or the data files. And these data files are the storage files or the database. If you talk about database, database is actually data where you're going to store. Database is kind of storing your end user data, whatever the transaction data, whatever my business data, whatever my application data, whatever writes into my database, wherever you're going to store it. Again, where you're going to store it. Yesterday we talked about that. You can store it in a OS file system, or you can store it in a ASM. I showed you that DevDB and TestDB, right? DevDB residing under your OS and TestDB is residing under your ASM. So that is a storage file, actual file where you're going to store. That is your actual data, you're going to store it. And the instance is kind of the resources, the memory structure where the users are connect and do a transactions. And if I can compare this instance and the database combining together, it's going to be your actual database or actual database server. And your instance is nothing but a human, and your database or the storage file or the data files are going to be like books. And this storage or the database or the data files, you can call it as the database or the data files or the storage files where you are going to store it. You are going to store it on ASM or you're going to store it on your OS level. Let's go it and check it out here one more time. If I can connect to my database here, this is my DevDB. Select name from one more time. Describe DB underscore data underscore file. Select file name from DB underscore data underscore files. So these are your storage files, your system, sysocs, users, undo. There will be a lot of data files your database will be having. As and when you grow database, you're going to keep on adding the data files like books, whatever, like we are seeing it here. As and when you will be keep on writing, as and when these files are keep on filling, and you're going to keep on adding a new data files. Those are like books, and those are like your data files or the database or the storage files. You're going to store it. Right now, this database, we are storing the files under OS file system. It may be SAN, NFS, NAS. And if I can go to other database here, .orinv and testdb, this is like storing the data inside your ASM. Run the same command, select file name from db underscore data underscore files. So it is starting with the plus. Anything start with the plus, that will be your ASM storage, Oracle provided storage, not the OS provided storage. Right? So that doesn't matter. You can store your database anywhere, NFS, SAN, NAS, or ASM, or any file system, doesn't matter. So those are your actual data. Whatever the end users or business user do a transactions, we will store it in a data files, like hundreds of data files inside your database. Right? That is our books, how you are going to write it to books. Similarly, all the transactions, whatever inside my database are happening, the creation of tables, insert data, and all those things, we're going to store it inside my data files. And then, like this human, he has this brain to store the data temporarily, and he has this pair of hands to do a write and do a read operations from the books to the books. Similarly, you have an instance which will be running under that particular server. That instance will have memory plus background processes. This memory is kind of how this human has a brain to remember the information temporary purpose. We have a memory inside my database instance, and we have a set of background process which will do write operation to my database and read operation to my database. So for example, user one connected to my database instance, and this is a client one, and he created a table called employee table. He created employee table, and that employee table has these many columns like employee number, employee name, and his salary. He has this table, employee number one and employee number one, and employee number one, his name is A, and he has a salary $1,000. Right? This is the information this user created. the moment the user connects, he will always connect to instance. They will never connect to my data files. They will never connect to my database. Again, remember, database or the data files, meaning your actual, the files where you are storing it in your OS side or in ASM. Those are your actual data files or the database or the storage where you're going to store the data. And the instance is nothing but just the processes running under that server. So anyone connects, they will connect to my instance first. Via instance, they will run all those operations. The moment this user create this table, employee table with one record, and the first thing it's gonna write it to that memory structure here. He will write the memory, and then we'll say that, boss, okay. And the instance will respond back to that client one. Okay, boss, your data is saved. And later, this background process, one of the background process will take that information and start writing into the data files, right? And then client 2 comes and he create one more table, T1. Again, that client 2 will connect to that instance and he will write write into memory the table T1 he created. And again, instance will respond back, boss, your data is saved. And later, one of your background process will start writing data into that data files. That's how the transactions works. Now assume that client 3 comes and he will again connect to my database instance and he'll say, he will just select employee table. What are the records inside employee table? He will do select statement. Record, read, he's trying to read that what is there inside employee table. What happens in that? If the data is already available in the memory, the instance will give that back. Okay, this is employee records already available here. Take it. And assume that the memory is vanished, like, data from the memory is removed. What happens? Again, one of the background process will fetch the data from the data files. It will bring it back to that memory. From the memory, it give it back to that user. The same architecture, whatever I correlated to my human life, the same thing happens in database as well. Each database will be having instance and particular data files. And then each data file and each instance combining together, it will form my entire database server. That entire database server is nothing but your host, the Linux server. Whatever the Linux server Oracle Lab 1 is the database server. That database server will be having an instance plus the data files combining together. It will form my entire database server or the Linux server. Right? Any questions here? How that we can correlate Oracle database and human life? The human is nothing but instance. Any end users want to connect to my database, they always connect to my instance. Nobody, you including DBA, we will not be able to connect to my database directly. Database means the storage files. We cannot able to do read write the data files or the storage files without instance. Instance is the one who is having the knowledge, who knows that how to write into data files, how to read into data files, right? Any questions, guys, here on this correlation?
Hi, Malik.
Mhm.
When we are using ASM, how to how to add data file.
Again, that is
When-
a further part. We will talk on that, adding the data files, creating that ASM. That will be like further discussion. Doesn't matter for now. Your data files are going to reside on ASM or NFS or SAN or OS file system. What you need to understand, actual data is going to store it in a data files. And to read and write that data files, you need to have an instance. Right.
It's okay.
Right. Let's go back now. We understand what is instance. Common question in interview, most of the interview. What is instance? Instance is a combination of memory plus background process. Simple definition. What is database? Database are nothing but the storage files or the data files or the actual end user data is going to store it in the data files. Those are called my database. Combining database or the data files with the instance will form my database server. That database server is nothing but your Linux server or the Windows server where you install your database. Right. Now, question comes. Is there any limit on each DB file? Like, is there any limit for each of books? Right. So you can have a books of 100 page, 200 page, 300 page, 400 page, right? Similarly, you can create a data files of 32 GB, 64 GB, 120 GB, 1 terabyte data files. There are certain limitations, certain conditions, how you can have multiple size books. Similarly, you can have multiple sizes data files. One is 32 GB, 64 GB, 128 GB, right? Similarly, you can have a multiple sizes data files. That's the first thing. Is there any limit to, sorry, that is the size of number of files. First is number of files, like, you can have write 100 books, 200 books, 1000 books, right? You can write it. Similarly, for each database server, you can create 100 data files, 1000 data files, 1 lakh, 1 million, no limit. You can have hundreds, thousands of data files. That's the number of data files, number of books. And is there any limit size of each DB files? Is there any limit for each DB, each database books? Whatever that user can write, right? He can write it into, he can buy first 100 pages book, or next time he can buy 200 pages book, and next time he can buy 1000 pages book, right? Similarly, you can have data files with a different size, no limitations. And then, is there any limit to size of database? Size of database means what? Combining all data file together, it become your entire database size. Combining all the books together, it will form your entire, like your stack of books, right? So you can have hundreds of data files with the different sizes and different storage, right? So everything you can customize here. There is no hard and fast rule, but there are some certain conditions you need to meet that first, and then you can do this one. Just compare with correlation, right? I can have n number of books, and each book has different pages, different size of pages, 100, 200, 1000. And similarly, you can have hundreds or 200 of books. Same thing, correlate, and then just simple understanding, you can able to answer the question. Right. Any questions so far?
Hi Malik, it's previous slide, last 1, 2, 3, data file size, no DB, no data file size of this, limit of this size of this is data file, is no clear. Please clear it.
There is no limit of number of files. In a one database, you can 100 data files, 200 data files, 1000 data files, no limit at all. Each data file have various sizes. It may be 30 GB, it may be 32 GB, it may be 40 GB, it may be 100 GB, no limit at all. And total size of your database is combination of your number of data files, how many data files you have it combined together, that will be your database size.
Data file has no limit, right?
No limit. That's what I did. Number of data files, no limit. And each data file has different size, and combining together all the data files will be your database size. Right? You can go ahead and then check it out. For this database here, I have 1, 2, 3 data files. And then I can add 100 more data files. And each of these files having various sizes. Combine all together, it will be your database size.
Malik, this is Jeevan here. So Malik, in my environment, we have faced this issue. Looks like there is a limitation of the data files, where we have the situation where the space was not there in the table space. I mean, it's a data file. So when we try to add that, so they have done you have exceeded the data file limit.
Again, we'll talk further on that. There are some conditions that purely depending upon your data block size. If you set your data block size 8K, you can create a 32 GB data file. If you set the data block size as 15K, you can create a data file of 64 GB. If you set a block size of 16K, you can create a data file size of 128 GB. So whatever the data block setting you have done at your database side, similarly, that's a limit of number of data files or size of data file you can create. I will discuss further on that, but what the generic answer should be, there is no limit for your data file. That is purely depending upon the block size. If I change the block size, I can increase the data file size. Right. Coming back now, that is about the database basic architecture. Somebody asked what is instance? It's a memory plus background process. Somebody asked what is database? Database is the actual data files which is storing under your OS or on ASM, where the end user data is going to store it on the data file. That's your database. Your data file or the database plus instance is going to form your database server. The database server is your Linux server where your database is running. Right. That's the basic architecture or basic understanding. And now coming back to the difference between standalone versus rack. What is standalone and what is rack? Let's go here. I have server Oracle Lab 1. And as I told, I'm gonna store my data files. Let's stay here slash Vora data. So here I'm gonna store all the data file. What are the data files? Data files are nothing but you can call it as a database. Data file and database are remain same, right? Like some people will call it as the data files and some people will call it as the database. So that is your data files or the database, or you can say OS files, because those are going to store it inside your OS or the ASM. So those you are going to store it in any of the mount point in your OS side. Right now you can see this is U01 is my OS side mount point, and all my data files are residing over here. And in order to access these data files, I should have my instance. That is my DevDB. And most of the times your database name and the instance name are going to be remain same. And if you see PWD here, my DevDB data files, all the data files. This is my database data files, all the data files, and PS-EF grep smon. This is my background process. Smon is a background process for that particular DevDB. And there's a pmon is again pmon is a background process for my DevDB. And dbwr, dbwr, dbw, just say dbw star. And we have dbwrm, dbw0. These are my background process for that particular DevDB. So in order to list out all the background processes for your DevDB, you can give the DB name ps-ef grep DevDB, and you can see hundreds of background processes here, right? So go back to slides here again. Your instance is nothing but a memory plus background process combining together, which will run under that Linux server. We're gonna allocate some memory from the RAM of that Linux server, and a lot of background process will get started. That is the instance which will run under that Linux server. And anyone connect to my instance, they will read and write of that particular data files associated to that instance. Let's quickly connect to my database, and then I can do shutdown and startup. Shut immediate. I'm going to shut down my database. Shut immediate. Again, we'll talk all this command in our actual course. I'm going to shut down my database. So this is like shutting down your instance. We are not going to operate anything. Remember, we are not going to operate anything directly on my data files, on my database. Whatever we operate on all my instance level, right? Like how anyone can read, talk, write, or do any instruction to human, whatever the DBA gonna manage or end user gonna connect to my database, everything at instance level. Via instance will operate my data files. Right now I connected to my instance, I shut down my instance. The moment you shut down your instance, nobody can access to your database, because that is like one-to-one mapping. One instance, one database is mapping. If that instance is down, you cannot access your data files. Let's go back here. So shutdown, instance shutdown, done. Let's exit and run the same command here. ps-f grep DevDB. There are no background process. The moment you shut down your instance, your background memory will be released and your process will be released. Let's go back and do this one. ps-f grep DevDB. Nothing. There are no background process. All are done except your listener, which will be running. But all your background process, whatever you are seeing, this bunch of background process here, all are gone, right? Because your DB is down, right? If I do ps-f grep smon, the smon is one of the mandatory background process, and pmon is again one of the mandatory background process. So Nothing is listening. So your DB is down now. Let's connect back to your database and then do startup. Startup is a command. You're going to start your database. The moment you start your database, it is not a starting of database. It is starting of your instance. The moment you start the instance, you're going to allocate the memory. You can see here, right? Variable size memory, fixed size memory, and your database buffer, your log buffer, and your database mounted and your database opened. So connecting to instance and starting your database, and now you can query these commands. ps-f grep smon, and your DB is started now here. And ps-f grep pmon, and your DB is started here. Like these are like background process to check your database is up and running. You can run this smon or pmon, or if you know the database name, you can run that command ps-ef grep your DB name. So there will be bunch of background process. Any instance you start it or any database you start it, some people will say instance start or database start. The moment you do it, it's gonna allocate the memory and it's gonna start the bunch of background processes. That's the basic architecture. Instance means memory plus background process. The moment you start the instance, you are allocating a bunch of memory structure and you are starting a bunch of background processes or the processes inside your Linux server. And now I can access my data files belong to that database, right? That is for your one-to-one mapping. Like in a Linux server, you created that instance, again, instance, memory plus background process for a particular database. And if I can go here on the Oracle Lab 2, exit, and ps-ef grep smon, one of the background process I'm checking here. This smon is listing smon for my test DB, smon for my test CDB, two databases, and it has its own background process. And again, ASM, I'm not going to talk right now. You create 100 databases, 100 databases will be having each background processes. And if I do ps-ef grep pmon, pmon is again one more background process, and test DB has a pmon background process. Test CDB also has pmon background process. This is one of the way you can query for one of the background process and to check whether database instance is up and running or not, or whether your database is up and running or not. Right, again, each of those having its own background set of background process. If I do for DB level, ps-ef grep test DB, and all the test DB will be having bunch of background process here. You have this VKTM, you have this VKRM, you have your DB writer, log writer, checkpointer, SMON, PMON, recoverer, archiver, so many background process. And similarly, you can do it for your test CDB, one more database, ps-ef grep test CDB. This is one more database, and that database also has its own set of background processes, right? So that is kind of one-to-one mapping. One database has its own set of data files. And if I can go back here in the slide, in a server, I can have multiple instances, and all of those instances are mapped to the respective data files or the database, right? And the question comes here, how many database servers, or I can say database instance, or instance we can install in a server, in a host or server or host. In one host, how many database instances or databases I can create? There's no limit at all. As long as this server has so much of CPU, memory, RAM, you can create a number of instances. You can create an instance 1, instance 2, DevDB, TestDB, UATDB. Right now you are seeing it here. In this particular Oracle Lab 2, I have a DB1, DB2, that's a instance 1 and instance 2. On this Oracle Lab 1 here, PMON, I have only one instance, one database here. Because this server has a very limited resource, very less CPU, less RAM. And that's no limitations. In a one server, you can have a multiple instances, multiple databases. You can create as long as that server has enough CPU, enough resource, enough storage. Right, that's the answer for that question. Can I have an instance and database in a different server? Right, you can have it. Your instance is running here on the server, and your database, data files, you can store it on the different server, but you need to do an NFS mount on that server. Right, as I said, this data files may be coming from your NFS, SAN, NAS, or the different server, or your ASM file system. You can have your data files. Data files is nothing but database. You can have instance running under one server, database running under other server, but make sure that that database or that data files should be mounted on that server as a NFS. That is possible here. Can I have an instance and the database? Database is nothing but data file on a different server. Yes, you can do that one. Different host, you can do that one, as long as you have an NFS mount point mounted on that server. Multiple databases on a single instance. For example, I have DB1, DB2, and I don't have this instance 2. Can I have with instance 1 connect to DB1, with instance 1 connect to DB1? No, we don't have that concept in Oracle. In the MS SQL Server or other architecture, one instance, multiple databases you can create. But in Oracle, one instance map to one instance, one database. And for example, let's 1 second, guys. Right, one instance map to one database and second instance map to second database. You cannot have one instance map to multiple databases. Let's go here. I'll connect to, there are two databases here. One is TestDB and one is TestDB. And I'm gonna set the environment now. First, I'm gonna go into TestDB here. SQL plus /SDBA. And I'm gonna run the same. I'm gonna list out all the data files of the database, like this command. Select file name. So this is my one database. Put it here in the notepad. So this is my one database, like one database is available here. This is like DB1. And let's connect to other database now. .org. And I'm going to connect to this other database here. And I'm going to run the same command. Where are my data files or the database for that instance? So this is my other database. And if you observe TestDB and TestDB, two different locations. You cannot have the database on the same locations. It has different directories and each database or each data files are in the different locations. And this is my second database. DB2. I have DB1 and DB2. And for this DB1, and I should have its own instance 1. And for this database, I should have my instance 2 separately. I cannot have a single instance to access multiple databases because those are like independent databases, like one-to-one mapping. You cannot have a single instance to access multiple databases. That's not possible with Oracle, right? Remember that. So answer to these questions are, you can have multiple database instances on a server as long as you have enough memory, CPU, RAM on that server. Can I create data files and instances on different servers? Yes, you can do that as long as you are able to do NFS mount. Your instance is able to access those data files. And multiple databases to a single instance. DB1 and DB2, can I tag it to one instance? No, you cannot do it. One instance dedicated to one database in Oracle, right? That is a single instance or standalone, what I talked. And assume that this server is crashes because of some network issue or some OS issue or some anything, like anything goes wrong with the OS, your server crashes, or anything wrong with the instance side, whatever that instance you created on that server, that process are killed. What happened to your database? Again, let's go back here. One scenario or one demonstration I can do here on this lab 1. These are my data files. Let's put them on the notepad here. This is my data file, DB data file, right? I can put it here. This is my DB. And in order to access these data files here, if I can go here on this location, these are my data files. You can call it as the data files or the database or the storage files, anything. In order to access these data files, you should have that instance, this instance. And if somebody kills that instance process, kill -9, the instance process somebody killed, or something wrong with your OS rebooted or network caused. And if your instance is gone, like your instance process is gone now, so you don't see any process related to that instance, like SMON is gone now, and you can check for the PMON and then gone. And you can check for that DB database name itself. Right, so everything is gone. A bunch of background processes all are gone because you killed one of the mandatory background processes. The moment you kill, so the meaning what I'm trying to say here, If your database server, data Linux server crashed, or the network issue, or the Linux OS issue, or the instance is crashed, nobody can access your database. Nobody can access your data file. That is going to be complete downtime because it's one-to-one mapping. And then how to overcome that? For that, Oracle came up with the concept called RAC, stands for Real Application Cluster. What that meaning? You have multiple Linux, your host, Linux host 1, Linux host 2, Linux host 3, multiple database servers, multiple hosts where you can create instance 1, instance 2, and instance 3, and you can have those 3 instances mapped to a common shared storage where your database is running. In that case, 100 users can connect to node 1, 100 user can connect to, or 50 users can connect to node 2, or 1000 users can connect to node 3. And what happens in this case here, if this server crashed, your host 1 is crashed, or your instance 1 is crashed due to some network issue or some OS issue, your server 1 is crashed, and automatically this all 100 user connected will be shifted to your second node or the third node. That is called something in rack TFA, sorry, TAF, transparent application failover. All these 100 users who are connected from application or from the end user to one of the server, one of the node. And if that node crashed because of the network or because of the OS issue or the host issue or the instance crashed on that node, all those users will be shifted to any one of your cluster nodes. And all of them will be accessing the same common database, which is stored under a shared location between all the 3 nodes. That is a beauty of your real application cluster. 2 advantages here with the React. One is HA. HA means high availability. So if you see here 100 users, 50 users, and 1000 users, altogether 100, 1000, 150 users. So if all the users are connected here, 1000, 150 users connected to one single server, your server will be crying, your server will be overloaded, right? To avoid that, you can distribute the load. Rack will distribute that load across all the cluster nodes and server will run optimally. That's the HA feature. And the second one is your failure, your transparent application failure. If any server crashes, automatically you're going to fail over to the other available instances. But whereas in case of your server crash or instance crash, all the users are disconnected. Here, the users can seamlessly continue to work. That's your rack feature, right? That's the difference between standalone versus the rack, right? So little bit further understanding on the standalone and rack. Let's go here. So in industry standard, any application they develop, it will be 3-tier architecture, and they will call it as a front end or a client or web or mobile or presentation layer. These all represent the same thing, front end layer, and the middle tier or middleware or the Apache Tomcare, that is your business logic, where your business logic runs or your application server runs. And the back end or database tier or data management tier is your database as a DBA we work on here. And if it's a standalone, as I said, one database mapped to one instance, that instance is running under that one single Linux server. And the end users they may be connecting from URL, web browser, or they may be connecting from mobile application, or they may be connecting from desktop applications. All will go to first application where the business logic runs. From that, they will all connect to my database instance, which is running under one of the Linux server, right? And if that Linux server goes down, if that instance goes down and nobody can access to my database, all the outage here for all the end user all over the globe. Whereas when it comes to rack, any users can connect to URL, mobile or desktop. They will connect to application server. From application server, they will go to either node 1 or node 2 or node 3, anywhere they can connect. And then from there, all they will access to my database. And then once that instance 1 goes down or the server crashes, automatically connected users will be fail over to any of the existing instance inside my rack. Right? That is your HA feature in rack, high availability or the transparent application failover. All will be supported in the rack. Right. Any questions so far on the standalone versus rack, as well as your database architecture, whatever we covered so far? Standalone versus rack, how many instances we can create, how many data files, how many database mapping, or connectivity between your standalone and rack. What's any questions anyone has?
Hey, Malik, one doubt. This I see Oracle DB is always running as Oracle user. Is there any scenario where Oracle DB will be running as a different user?
I told you, right? It is all left to you. You can run it with Oracle user, Vora.dev, Vora prod, Vora UAT. You can create that OS user and create your database.
Okay.
No limitation. Right. Right. So let's quickly cover one more topic and then we can close it. So now what all we understand? Yesterday we understand database software installation, database creation. And now today we understand how DBA can connect to database, how the remote connections happens. And now we understand about database architecture, how that anyone connected to my database, and it's not data connected to my database, it's all connected to your instance. Always we DBA or the end users, always we connect to instance. Via instance, we will access our database or the data files. Your instance is kind of a mediator. Any transactions, read, write, whatever it is, happens at your instance level, right? And then we understand about standalone and rack. And then it is not that simple. Whatever I talked about, instance is just like memory plus background process, and database is just like a storage files or data files. It's just simple to understand if I talk like this. But if you go in real fact, your database, or let's go here, instance and your background process and backend database or the storage. This is again simple architecture I put down here. Instance I told already, it's a memory plus background process. And inside memory, you have a SGA and you have PGA. Whatever green color you're seeing it here, these are like memory structure. We have memory structure, two important memory structure. One is SGA, that is shared global area or the system global area. And we have a PGA, program global area or private global area. Again, we'll talk further more in actual classes. And again, each of those memory component, your SGA has so many subcomponent and your PGA has so many subcomponent. For example, your SGA has shared pool, large pool, Java pool, stream pool, database buffer pool, and redo log buffer pool. So many memory component. So inside memory, there are so many sub memory component. And background process, as I already showed you here, like hundreds of background process. And some of the mandatory background process are like checkpoint, smon, pmon, dbwriter, logwriter, checkpointer, archiver. There's some of the background process I'm showing it here, but they're like ideally arc, tt0, arc1, arc2, tt02, like so many background process for each database instance, right? That's one thing. And then database, I just talked about data files. And just I given some example here. You have a control file at the storage side. You have a data files at the storage side. And we have an online redo log file. You have an archive log file. There's so many files. And in this diagram, I just told, okay, just like a storage data files. At the storage side, you're going to store it. And then I just queried one command here to list out all the data files. Like I just ran this command, I showed only this much. But ideally, if you talk, how many files we have at storage side, there are so many different files. What are those? Just to brief you. And if I can go here, you have a control file on the host storage side. You have data files. You have a temp and undo files. And you have online read log files. You have a archive log files. You have a backup files. And you have a SP file and a P file. You have a password file. You have a alert log and trace file. These all are like backend storage files. And ideally, your data files is the backbone for your database where your end user data is going to store it. But that is not enough to run your database or run your instance. Along with the data file, there are so many other files. You can see it on the OS side, right? Those will be like discussed in details when we start the actual class. Like this is like just example. If somebody asked what are the backend storage files or what are the data files, and give me some examples, what are the storage files for a database or for an instance. Somebody asked like that, you can see on the storage side, we have so many files. In order to run your database or in order to run your instance, we need a control file, we need a SP file, P file, we need a data file, we need a undo temp, we need a system, sysocs, we need online log files, archive log files, we need a password file, alert log file, trace file. There are so many files will be discussed in details, right? Similarly, same thing goes for your memory structure, a PGA and SGA. Inside PGA, we have a stack space and user global area. And inside SGA, you have a seed pool, large pool, database buffer pool, Java pool, redo buffer pool, and stream pool. So these are like your memory structure, right? So this is overall architecture, how the database will operate. I'm just going to cover here one sentence. If somebody asked you, can you explain about database architecture, or can you explain how database connections works to my database, and can you brief about database architecture or the database structure? In any of the questions or in any of the interview, there's a common question they will ask. So your answer should be any end users, the client who will connect to my database instance using a username and password and TNS name, right? That's a mandatory. I already showed you that how that user will connect using a TNS name. And the moment he connect to my database instance, try to connect with a valid username and password with that TNS name, there's a listener process will be running under my server, database server, where the database is running. That will take that incoming connection and it will validate whether that is the username and password is authorized and whether he's giving a correct TNS alias or TNS name. Once the listener validate all those connections, listener will come back. Okay, hey boss, your whatever the credentials you passed, whatever the TNS details you used, everything looks to be optimal, everything looks to be correct. Go ahead and connect to my database instance. And that user process, user session will connect to my database. And then the moment he connect to my database instance, one process will start. Whatever this user runs query, whether it's a select query, whether it's an insert query, whether it's update query, any transactions he will do inside my database instance, that server process will take that query and execute inside your database instance. And the moment execute inside my database instance, if it is the insert, again, it's going to go ahead and store it in the memory. And later, one of the background process will take that and write into data files. And if that user is doing a read, and again, server process will request for that. Okay, this user is reading this data. Can you provide? And again, that server process will get the data from the data files to your memory. From the memory, will give it back to that user. The same thing, whatever we talked about here, right? Anything read or anything write with the help of memory, we'll do it in the memory. And with the help of background process, we'll do read to a data files or write to a data files. Right, that's your overall architecture. And again, who is going to read that operation, who is going to write that operation, and all those will be discussed in details when we start our actual class, right? This is all your overall architecture, how that end user connections works. And once they're connected, they'll always connect to instance, and whatever the query they will do, whether select, insert, update, whatever the query, the server process will execute on behalf of that user session, and they will execute inside my instance, inside my memory structure. When they do insert or update or select, based upon what transaction they're doing it, the result will be given back to that end user with help of setup, background process, and this memory structure. All right, so that's the overall architecture what I wanted to cover as part of this demo sessions. Any questions before we stop it for today or before we close for today?
Malik, what is the role of cursor in this connection? I mean,
there are a lot
like
of things. That's again internal. There's so many other internal things, and what query he is running. This user may be running just a select query or insert query, some PLSQL procedures, some triggers, and based upon those, the other sections will come into picture. How long he's running, 1 hour, 2 hour, 3 hour, and based upon that, the cursors, how much time it is opened, how many time it closed, all those will internal again, we'll talk on in regular classes.
okay, sure.
All right. Anything on the database architecture or database connectivity or the database installation, whatever we covered yesterday and today, or in fact, anything on the course content you want to discuss? All right, I'll take a pause for 1 or 2 minutes, and if there are no questions, then we can close this session for today, and then we'll see you on Monday with our regular classes. All right.
Hi Malik, Bharat here actually.
Hey, Bharat, yeah.
Actually, configuration, I had 8 GB RAM and 120 GB of hard disk. Is this okay for practicing on Appx service actually?
Right. That's a minimum requirement. You should have 8 GB RAM and minimum 100 GB hard disk in your laptop or in your desktop.
Oh, okay, sure. In all further concepts and data, everything can be practiced, right?
I think some network issue from your
Thank you,
end. Can
Mike.
you? Yeah. Any more questions, guys, before we stop it for today?
Is it okay to is it
Some
okay
net-
to practice data guard with this?
I think there's some network issue, Bharat. Just go on a mute, or you can ping me on my WhatsApp. I'll talk to you.
Okay.
Yeah. Any more questions, guys? If not, then we're good to wrap up. Thanks for joining this session, and we'll see you on Monday with regular classes. Thank you, everyone.
Hi, Malik.
Yeah, please go ahead. Go ahead.
Mondays started class 6 February.
Yep, that's correct. I'll who are registered.
What is the schedule of this class? This is again Monday starting
Same
20
timing, 6th February, and whatever the demo timing, it's the same timing for your regular
Friday,
classes.
Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday. It's all the in a week in 6 day or 7 day, whatever. Please clear us.
Yep. We'll talk on that in our group. All right. Any more questions?
Okay.
All right. Let's stop it now. We'll connect you on Monday, guys. Thank you. Thanks for joining. Have a great day.
Thank you, Malik.